Okay, we proceed. We proceed that, okay, this is an elliptical circuit lah. Elliptical circuit. Normally, when we see elliptical circuit, for sure the law that we must use is, normally when you see an elliptical circuit, what is the law? K, KVL and KCL. So this is synonym with RC, with electrical circuit lah. Very synonym lah. Alright. In order to solve it, you must know how to do KVL and KCL. Without this knowledge of KVL and KCL, you cannot solve this question. I do the same thing with the other class. From A, B, C, can you choose A or B or C? A, okay. One to eight. From this group, 1 to 8. 1 to 8? 7. One to 6. 5. 4. 1, 2, 3, 4. This is A, B, C. 7 kan? 1, 2, 3, 4, 5, 6, 7. Yeah. And then number 4 from 1, 2, 3, 4. Okay. Come forward. Okay. Mujuk ah. Can you write down the KVL for me? Cuba lah. I give you a hint. KVL is a voltage equation. I give you some clue lah. In order to write the voltage equation, so you must name this voltage is VR, voltage across capacitor, resistor, and YT ni from the question is voltage across capacitor. So now you have voltage for the symbol voltage for the input is XT. The voltage for resistor is VR. The voltage for the capacitor is YT kan. So you try to arrange XT, VR and YT in KVL form.
KVL form
Cuba. So based on 1, 2, 3. 1, 2, 3. You just write down positive, negative ke, minus plus ke, XT minus VR ke, VR plus YT ke equal to XT ke. So just write it, no problem.
XT XT plus VR.
Just write it. Because KVL is a voltage kan. So it means that you must consider the voltage across the component lah. You have resistor, so it means that you have voltage across resistor. You have capacitor, so it means that you have voltage across capacitor. You have input source, the voltage is XT. Okay, YT positive or negative? Minus or plus? Ha. Dah record lah. Dah. Equal to 0 lah. Equal to 0. Dah. Okay. Anyone would like to comment? Is it correct or wrong? Wrong. Which part is wrong? Plus what? Once again? XT plus or minus VR? Minus VR plus or minus YT? Minus YT equal to 0. Okay. Alright. I will call you after this, after I teach how to do the KVL. Then I will test you again. So is it you gain the knowledge or not? Okay. Alright. Okay. Gelap-gelap. So maybe after this your turn will be. Okay. Alright. So I teach you how. By know this fundamental, whatever how many loops, 5 loops ke, 10 loops, you still know how to do the KVL easily by using this knowledge. The knowledge is we use magnet. Magnet, how many poles they have? Positive and negative kan? Magnet lah. Magnet you have positive and negative. If we have 2 magnets here, 2 magnets. First magnet is negative, the second is negative, it will repel or retract. Repel kan? Repel, so we can say repel equal, we can consider equal to negative lah. Okay? If the magnet positive and positive, repel or retract. Positive will be negative. Okay? If positive and negative attach to each other, is it? The size become bigger or smaller? Bigger, right? Because 2 magnets combined together, it will become bigger. So that's why positive, negative, and then negative, positive, positive. We use this knowledge lah. Okay, I'll give you this one. So that's why I told you that this explanation can up to half an hour. Okay, so this is the voltage source R, C. This is the power supply. The current will going up from the power supply. From positive, it will travel until it return to power supply. One cycle. Okay. So you can see that this is voltage source. The resistor, is it produce voltage or accept voltage? Accept it. The capacitor produce or accept voltage? Accept from XT. So it means that when the current go any component that accept voltage, it will be positive and negative. The current going in will be positive, going out negative. Okay. Next. Now we want to write the KVL. If you want to write a KVL, you need to set one. There are 3 things, 1, 2, 3. You need to set one thing as a reference. In this case, I set XT as a reference. So when you set XT as a reference, so you need to write down XT first. Okay, you set xt as a reference, you need to write down the xt. After that, you need to compare the reference with every other component. So in this case, XTN, you need to compare with the R first. Oh, sorry. You need to name it as VR because voltage kan. You need to rename as a VC. But in the question, VC equal to YT lah. Okay? Because of the question. So you need to compare XT with the VR. You need to compare XT with the YT. Okay. So from the XT, the sign that going up from xt is positive, and then you compare with the VR, what is the sign that emit first? Positive, positive, negative what? VR. Okay. Next, we already compare with VR. Now we want to compare with the YT. So now we need to use the same reference, and then what emit first? Positive, 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 negative, YT. Any other thing? So equal to 0. Like that. Okay, that's how you do the KVL. Do you want me to challenge you with more complicated? 2 loops? Okay, 2 loops. This is settled. So this is how xt minus VR minus YT equal to 0. Okay. So normally the question will be like this, right? So how many KVL do you have? 2 KVL, because you have 2 loops. One loop, 1 KVL. The other loop you have another one. So loop number 1, loop number 2. So you will have 2 KVL's equations. So loop number 1. KVL lah. Remember the first thing you need to do is you need to draw the current. Because only this is the voltage source. So the current will flow here, and then will be divided to things, and then they will combine together until it return to negative lah. Okay. Firstly, you need to draw the current flow, and then after that, when going in will become positive, going out, going in, going out, going in, negative, positive, negative. Next, what you need to do, you need to label the voltage name. So this one will be VR1, this will be VR2, this one VR3, VC. Negative. Negative VIT equal to 0. Like that. So is it Chomeng use VR1 as reference? So you can use VIT as a reference, no problem. VR1 as a reference, VR2 you can do. You can choose anything as a reference. But Chomeng use VR1 as a reference. So since VR1 is a reference, you put the first one. The reference must be positive or negative? Positive. So negative meet positive? That's why positive VR2. Negative negative VIT. Anything else? Equal to 0. So the second reference, we try VIT as reference. So we try VIT as a reference. So the reference will be positive first. So positive and positive, negative VR1. Positive and positive, negative VR2 equal to 0. If we rearrange again, actually they are same, yeah? Same thing. Okay. So we go to the second. What's your name? Siva. Siva use VR2 as a reference. So when use VR2 as a reference, so positive and positive, positive positive, negative VR3. And then positive and positive, negative VC equal to 0. Macam itu saja untuk KVL. Okay, what you need to remember is a magnet.